All right, so in this video, I'm going to go through sample question 11 from the Society of Actuaries Exam-P list of sample questions. The question reads, "An actuary studying insurance preferences of automobile owners makes the following conclusions." And it gives us three sets of information, three pieces. An automobile owner is twice as likely to purchase collision coverage as they are to purchase disability coverage. The event that an automobile owner purchases collision coverage is independent of the event that he or she purchases disability coverage. Last, the probability that an automobile owner purchases collision and disability coverage is 0.15. We're asked to calculate the probability that an owner purchases neither collision nor disability coverage. All right, so first thing is to just write to the side what we're given. I want to just condense all of this information into something a bit more easily readable, easily understandable. So let's decipher the first piece of information. An automobile owner is twice as likely to purchase collision coverage as disability coverage. So I can write that as the probability of getting collision coverage, probability of C, is equal to 2 multiplied by the probability of D, getting disability coverage. Event 2 says the event that an automobile owner purchases collision coverage is independent of the event that he or she purchases disability coverage. Now that's an important piece of information, okay? Independent would mean they don't affect each other. You should be fairly familiar with that concept. What you know about independent events is that the probability of the intersection of those events, so the probability of C and D occurring, is equal to the probability that C occurs times the probability that D occurs. Okay, that should be a pretty that should be something you understand fairly well, right? It's a very straightforward fact about independent events. Definitely have this formula memorized. The probability. The third thing is the probability that an automobile owner purchases both collision and disability coverage is 0.15. So the probability that I get collision and disability coverage is equal to 0.15. I can immediately see I'm probably going to need to relate these two, right? Next, we're asked to calculate the probability that an automobile owner gets neither collision nor disability. Right. Probability they get neither collision nor disability. Right? Nor the same thing as and. You'll see that word a lot. So all of this stuff and the question itself boils down to these four pieces of information. Now, I always say make a diagram, right? It makes problems much easier to understand. So I'm going to explain this using Venn diagrams. Right, here's my whole sample set, right, of all automobile owners. They can either get collision, they can either get disability, I made these too small, or they could get neither, they could be out here. The one thing we're told is that in here, that's 0.15. And what are we asked to find? We're asked to find what's out here. The probability that somebody gets neither collision nor disability coverage. So immediately I kind of want to say, okay, if I can set up a certain formula, right? Now, if you know the following, the probability of C union D, you can get this. Okay, they're complements of each other, and that's a fact you should fairly know involving De Morgan's law and the fact that an event and its complement should sum to 1. Okay, basically 1 minus this gets you this. So let's see if we can find what that is. Probability of C union D is equal to the probability of C plus the probability of D minus the probability of C intersection D. Now, here you might see we run into one main problem. We don't have enough information to actually solve this, right? We're going to need 3 of the 4 pieces of information, right? We know this, we know the intersection given to us as 0.15, and we kind of know what C is, right? We can replace that with 2 probability of D, but we don't know probability of D and we don't know the union. So this isn't going to help us. What we can use is this. All right, so here we're given that the events are independent, so that means the probability of C intersection D is equal to the probability of C times the probability of D, and that's equal to 0.15. Right? I'm using the first and second the second and third pieces of information they give us to determine that. The first piece of information says probability of C happening is equal to 2 times the probability of D. So 2 times the probability of D times the probability of D is equal to 0.15. Now I multiply this. 2 times the probability of D squared is equal to 0.15, and I can solve this algebraically to get the probability of D. So doing that, I would divide 2 to both sides and get, using my old trusty TI-30, the probability of D squared is equal to 0.075, and taking the square root of both sides, where's the square root function? There we go. We get, it equals this long thing. So the probability of D is equal to 0.2738, and so on. In my calculator, I'll just store it as X and use that, right? The less rounding I do early on, the more exact my answer is going to be later. All right. So now that we know D, we can figure out this union quite simply, right? So the probability of that intersection, of that union, C union D, is equal to the probability of C, which is 2 times the probability of D, which I have from up here, plus the probability of D. And I'm just not, I'm going to replace probability of D with that long kind of decimal. I'm just not going to write it out here, minus the probability of that intersection, which is 0.15. All right, and now I simply just solve for it. So 2 times the probability of D plus the probability of D minus 0.15 gets us 0.67158, repeating, or not repeating, but and so on. So we figured out what essentially this stuff is all in here. And since we know these are complements, we can figure that the probability of what we're looking for, which is C complement intersection D complement, is equal to 1 minus the probability of C union D. And C union D is this, so I simply just do 1 minus the answer I got from the previous step, and I get my final answer of 0.3284416. The answer choices are to 2 decimal places, so I'll round at this point and get a final answer of 0.33, leaving us with answer choice B. Okay, so this problem, if you're kind of going in sequential order, a little more complicated than some of the previous ones. However, it still required essentially the same knowledge. With one exception, this is, I think, the first, if you're going in order, that talked about independent events. So, brief overview of the problem. What can we learn from it? Well, like I say in a lot of my videos, probably is, write down what you're given, draw a picture. It'll make things much easier. We also see how important this particular formula is for a union. One thing you should know, independent events, their intersection is equal to the product of each individual probability. So the general formula that you might see in a textbook or a formula sheet or whatever would be the probability, if they're independent, this is only when they're independent, the probability of A and B is equal to the probability of A multiplied by the probability of B. All right. The last thing, and this has come up in multiple problems here, is the fact that, say you have the probability of, and this is a more specific case of using De Morgan's law and that whole, and the following. I'll first start off just saying the probability of A plus the probability of A complement. So the probability of A and everything not in A should be equal to 1, right? And De Morgan's law tells us that the complement of A, not A, intersection not B, right, is A union B. So therefore, if I were to just write to the side here, the probability of event A complement intersection event B complement plus the probability of A union B, that should equal 1. Okay, and that is super important to get comfortable with. A lot of problems will involve that concept, especially all the stuff in general probability. Hopefully I've tried to explain that as thoroughly as possible. If there are any questions that you may have or any sort of clarification, throw a question in the comments. I'll answer it as best I can. If there are any comments other than that you'd like to make, anything I could do better here, just let me know. If you want to see some more questions, I should have a playlist. I'll be adding videos to it as much as possible. And if this video helped you out, why not give it a like? Because that definitely helps me out. Other than that, good luck, guys.